Good evening, one and all. I'm Lalita Shankaranarayanan. I'm associated with High Media for the past 18 years. I work here as an assistant R&D manager in the Department of Molecular Biology, High Media Labs. First of all, I would like to thank all the participants for your tremendous support and your positive energy throughout these crash course sessions. We launched our first course on May 30. Then till now, you're giving your support. Thank you so much for that. I hope you all had an enriching experience throughout the last 7 sessions. I would like to extend a warm welcome to each one of you once again for this concluding 8th session. Hope you all will have another eye-opener session. So let's move on to the topic. So today's topic is about quality control. So let's dive into that. What is quality control? Can anyone say? So what is quality control? The term itself says, like you have to control the quality of your products within the predefined specification. So that is called as quality control. Let's see the definition. So quality control is a process through which a business seeks to ensure that product quality is maintained or improved. It's a process. Quality control can also be abbreviated as QC. It's a short form. We each and every time we don't say it's a quality control. So we often mention it as a QC. It is a process through which a business seeks to ensure that product quality is maintained or improved. You have to, like each and every time whenever the QC is carried out, so it is like each and every time, by the time the quality of the product should be improved, and customer satisfaction is the main criteria for this. So why this quality control is required? The first criteria is the product should be within the defined specification limits. So there is some criteria which has been already predefined for that particular product. For example, if you take some of a chemical, like molecular biology grade chemical, since we are presenting, from a HiGenoMB team. So I can take an example of a molecular biology grade chemical. So we have a defined specifications for a particular chemical. So that this quality control, it ensures that the product falls within the defined specification. That is the primary requirement. And the next thing is damaged products do not end up with the customers. The customers should not face any issues or problems while receiving our product. So that is, these two are the main criteria why the quality control is required. Next is quality control enhances. Like how, like why this quality control? Now just we have seen that why this quality control is required. Now we will see what are the parameters which this quality control enhances. One is customer satisfaction. Second one, compliance with standards, risk mitigation, continual improvement, cost reduction. Now we will go in detail, brief about what are these points. First is customer satisfaction. So through the quality control, how will you enhance the customer satisfaction? First thing is, if your product meets the proper quality standards, then it meets our customers' expectation also. Then once the customer's expectation is fulfilled, they will become your trusted partner. Then they will become your long-term customer. So customer relationship will be maintained. Then these customers will become a repeated buyers, and they will suggest your products to their friends or their industrial friends, their colleagues and everyone. So we will get repeated orders from the same customer. We will also get a new buyers also. Then major thing is brand building. So a brand will be built. If the customer is satisfied, these are all the 5 parameters which can be met with the customer satisfaction if the QC is in place. Next thing is compliance with standards. So now the world is like, without any compliance, nobody will accept the product, especially in the field of diagnostics. It is very much essential. Now the diagnostic standards have been like very much streamlined, and it has been like this very much stringency has been came into place after COVID things. So quality control plays a major role. If your quality control is in place, automatically the compliance will come. So it will be very easy if a stringent quality control QC is in place. We can easily be compliant with the standards, whatever it may be. It may be some ISO standard, the basic standard ISO 9001, or the higher level standard. There will be different standard for different product requirement. So if a quality control in place, then this compliance with the standards and regulations will also be in place. Then the commitment to the quality will also be in place. Then it will ensure that the manufacturer is following on ethical business practices. So these are all the things will be in place if a quality control is there. Next parameter is risk mitigation. So quality control enhances risk mitigation also. Risk mitigation means this is like, first, it will reduces the risk. If a quality control is in place, it will reduce the risk first. So what can be the possible risk? Suppose we can take one example. Now we are producing some reagent X. Okay, so we have taken a production of 2 to 3 liters. For example, I'm saying, and now we have to aliquot that into 100 ml bottles. So this is what the procedure goes for a reagent. Okay, so during aliquation process, we came to know that the bottles which are used for the aliquation of that reagent, it contains some fibers or some particles which was already present in that bottle. If that bottle was not being assayed properly or QC'd properly, the bottle has been passed and it was in stock. The person who was taking the production, he took the bottle and he has aliquoted the reagent. Now it is a risk for that reagent because we have properly done the production, but while during the aliquotion process, this problem has happened. So if the bottle has been QC'd properly, this problem has been identified at the earlier stage and the entire lot of bottle must have been rejected. So this cannot be, I am just giving the example of a risk. So if you do the QC properly, it can reduce the risk. Rectifying defects. If that some defect has been occurred, how to rectify the defect? Because if you do the QC in a proper basis, so you will encounter many issues also. If you are not at all doing anything, you don't even know that what a possible risk can come and what can be the defects. If that quality system is in place, the QC will be done in a proper stipulated time, and you already having some protocol to rectify that defect also, then it will minimize the product recalls. Of course, production and then QC, then packaging, dispatch, everything is a like time consuming as well as resource consuming as well as cost consuming also. So if you do quality control in a proper way, it will minimize the product recalls. Again, it will reduces the customer complaints. So in turn, it will maintain the reputation of the company. So these are all the 5 major criteria parameter which covers under risk mitigation. Next, we can talk about continuous improvement. Continuous improvement, if you see the graph itself says by the time, the quality will be improved. So this is what the graph says. For example, I'm again taking an example of a reagent. So today I have launched a reagent which will be having a pH of 4.5 to 6.5, and the clarity should be from clear to light yellow, something like that will be the appearance, and 2 or 3 other parameters. So my customer is accepting that parameter. Within that parameter, my customers are taking my product and I'm selling the product. But after some time, after 2 or 3 years, some of the customers are asking me, like, we want to take your product, but we require that product to be like fall in that specific parameter. Like we want your product to be like endotoxin free. Someone can say, I want that human DNA free, something like that. So these are all the specific requirements from specific customers. So by the time my product has achieved some place in the market, our product, so by the time, by taking the customer's feedback and doing the QC also, so it is getting improved. So I have increased the specifications. So we are thinking like we will talk to our team, we will discuss with the R&D team, we'll talk to the top management, and we will incorporate those parameters so that the quality of the product is getting improved from time to time. That's what the graph says. And this can also be called as continuous improvement. For continuous improvement, ongoing learning is very much essential. So if you are not improving or improving your specification, then the product will be at a single place. It won't move, like it won't suffice the customer's requirement. So the quality control, proper quality control, stringent quality control improves the quality of the product. And at one point of time, we will reach a graph like before 5 years, my product was complying with these specifications. So after 5 years, the same product is complying with so many specifications. So that is possible because of the proper quality control. Next is cost reduction. So quality control plays a very crucial role in cost reduction. So if we do the quality control properly, it reduces the defects and errors which can happen, heavy losses. So, and avoid expensive rework. If some product is not passing in the pH, for example, the raw material for X reagent is not passing in the pH range. Suppose I have taken one tris hydrochloride, we can say the pH range should be between 2.5 to 4.5. So I have not done the QC in a proper way. I have passed the material. It has went into the production. Now in that production, that person is making 1 molar tris and he has made some 10 liters or 15 liters. Now what will happen? It will say the pH of the tris, 1 molar tris using that particular chemical should be between the range of 2.5 to 4.5, but it is going up to 5.5. So if the quality control was made in a proper way, done in a proper way, this must have been avoided at the raw material level itself. So here quality control plays a very major role. So the expensive rework can be avoided because the time of that production person, the entire lot, because the company is paying to that particular person his time, the entire lot, everything has been wasted. Now it has to be reworked to cut down the pH up between 2.5 to 4.5, extra QC pressure and everything. So this can be avoided if a quality control has been done in a proper way. Then it minimizes waste. Now, what we have discussed is just something about some small like issues such as pH. It can be like men, but there are some issues which you cannot be able to rectified. So the whole product, it has to be wasted. So if a quality control is in place, then we can minimize the waste also. Then optimize resource utilization. So proper utilization of resources will be done if the quality control is in the place. Then it promotes operational efficiency. Exactly, it will be like if the person is taking a production of that lot, it comes to QC, it failed in QC, again the rework has been done, again the same lot has been produced, again it comes to QC, so it increases the operational cost. So if that has been done properly, QC has been done properly, then it will like promotes the operational efficiency also. Then we comes to types of quality control. There are 5 types of quality control. Like quality control can be done in 5 different ways. One is a preventive quality control. Next is a detective quality control, sorry. Third one is a statistical quality control. Fourth one is on-site quality control. And the fifth one is an off-site quality control. So now we'll see it in detail. First one, preventive quality control. So what is called as preventive quality control? Preventive quality control is nothing but identifying and addressing potential issues before the issues is being caused. That is called preventive quality control. Before you go through with any of the defect, if that product has been stabilized and the QC has been done properly, and I said properly, so it is called as preventive quality control, identifying and addressing potential issues before that issue is getting occurred. So what are all the criteria which can be used to achieve this preventive quality control? First thing is employee training. The person who is there in the QC, like this is not only applicable to QC, it is in the production area also, it can be applied. Just the topic says the preventive quality control. For example, a person who is taking a production, he or she has to be trained properly. For first thing, the person should have a proper education to take the particular task. Then he has to be trained according to the SOPs. So basically SOPs are to be in place, and that person has to be trained properly for that particular activity, and he has to be well informed, like with the production procedures and everything, how to do a calibration of the weighing balance, how to clean that production area, what are all the preliminary requirements which are required, line clearance, whether the line clearance has to be there or not, that also he has to be very much aware of. So basically the employee training is very much essential. Next step is equipment maintenance. So equipment maintenance plays a major role in whatever the essays or whatever the production parameter or something like that. Equipment maintenance is one of the major criteria. If that equipment is not working properly or the maintenance has not been there, then it can affect the efficiency of the final product also. So for example, if the weighing balance was not being calibrated properly, so I am weighing 1.2 gram, like 1.2 kg. So 1 kg and 200 gram, if that weighing balance was not being calibrated properly or there was no proper maintenance, something like that, so it is not giving a proper value. That might not be 1.2 kg, that might be 1.19 kg, some 10 grams or 20 gram difference, or it might be 1.25 kg. So that might affect the efficiency of my end product. If I'm making any reagent for, again, I'm saying 1 molar dress. So For preparation of 1 molar tris, you have to add some so and so quantity of powder in so and so quantity of like 900 ml of water or something like that. I'm weighing some 200 gram. So it is not 200 gram. Then the final product would be, it is not 1 molar. So it affects the final efficiency. So the equipment maintenance is also equally important. Then the third is process optimization. The process should be optimized. Like there should be a set of work instruction which has to be provided to the personnel who is taking care of that particular assay. That has to be optimized and it has to be standardized, and the standardized has to be standardized procedure has to be documented, and the person has to be trained properly. Then only this preventive quality control can be in place and the defects, reworks and waste can be avoided. Next is detective quality control. So what is detective quality control? We have done with the preventive quality control. We have taken a production, everything irrespective of the preventive quality control. There can be some flaws. So identifying what has happened. So this is called as detective quality control. So this is like basically identifying errors after process. The process is done, everything is done, the product has been given to the QC team for quality control. In that, we came to know after like doing the functional assay, we came to know that that product is not passing. So why is it not passing? Then you have to trace back all the, like from back to back, you have to do the traceability work. So that is called as detective quality control. I can give you one real-time example also. We have received so and so reagent in our QC department, and we have done the QC of that reagent. Ideally, the parameter which we have set, the specification which we have set, it should be like 1 mg per ml. But we have in the assay, it was giving like higher concentration. We were just thinking why this is happening. Like we have not, like I said, the quantity first, but we have done the protocol first. After that, after seeing the results, we were very much like confused, like why the results are getting, we are getting 10 times more values, absorbance values in this product. So at that time, then we had to like jot down first doubt will be with the QC person, because we don't in the first go we don't doubt the production process, because the standard procedures are already there, and the production person, like very much highly skilled person will be there in the production. So first doubt will go to the quality control person who has done the quality control. So we had to done like how she or he has done the quality control, how much like, but what was about the earlier batch. So earlier batch was giving proper results, the same person has done. So we had to ask her or him to repeat the procedure. So I'm explaining you the real-time process which is happening in a manufacturing industry like us. I'm telling you the real-time problem which we have faced 5 years before. So we had told the person to repeat the QC. Again, we have got the same result. Then again, we have told another person who is on the immediate senior. She has also got the same results. So after that, we came to a conclusion. This was not the problem with the quality control person. This must be something related to a production thing. So we, as it like we measured the value of that particular protein which is present there within the product. That time we came to know that instead of 1 mg, the protein was present in 10 mg concentration. That is like 10 times more than what should be there. So this type of like, then after that we had to mitigate the problem, escalate the problem. We had to tell the production people that this was not the thing, you have to do like this, that. And there was a very identifying a problem is not a big thing, but after that, how will you like root out the problem? how will you take care of the next production lot, and or like it affects the entire cycle of the industry, because will be like the product will be in high demand. If you are not giving the product on time, then it will affect your reputation and everything. So this detective quality control is like very much important. It should be in place, but it's a time consuming thing. So preventive quality control is the best thing, so that you can avoid these kind of issues. So this can be done, as we have already discussed, this can be done by inspection, testing. Sometimes it will be seen, if the concentration is high, it will be seen physically. If it is a colored product, it will be seen physically. So, or else you have to do the testing. So these are two different types of different parameter, physical and functional parameter, which can be able to detect the cause of failure. Basically, the goal is to detect and address the problem. So this is the basic goal of this detective quality control. Next is statistical quality control. So as the name itself says, statistical quality control uses statistical methods. Statistical methods is nothing but quantitative analysis, like measurable methods. So if you measure, if we will come to know, always one thing people have to remember, quality control should be done against a standard, always, at least a functional quality control. So if you are testing any chemical, so there are already predefined parameters. So it will be like, if you test, if it is within the range, then we can pass the material for chemical. So for some functional QC parameters, like you have to assay the DNA extraction, you have to like do a PCR. So these are all the functional parameters. There also, this statistical methods plays a very vital role. So while doing the functional parameter, we have to always like keep a standard. The standard can be any standard company kit. You have to keep, like if you are doing a QC of a DNA extraction kit, for example, to say bacterial DNA extraction. So the reagents have come, the entire kit have come to you for a QC, and you have to test the kit. So against that, you have to keep a standard kit. What can be a standard? It can be any of the available, like commercially available kit from a standard company, or your previously passed lot. This should be kept as a control while doing an assay of a kit, or if you're doing some functional QC. So after like doing the QC, you will get the results. The result will say, from that particular kit, the expectation is, for example, like I should get 1 to 5 microgram. I'm just saying for an example, 1 to 5 microgram of DNA yield in that particular kit. If my control kit is giving, like which I have already essayed, like I'm doing simultaneously. And another thing, you have to do a QC along with the control standard simultaneously. It cannot be like, today we do the protocol of that control kit, and tomorrow if a test kit when it comes, I will do only that. No, it cannot be considered as a control. Always, whenever you are doing a QC for a particular product, especially during functional QC, it has to be assayed simultaneously with a standard. So that you will get a comparative study. After seeing the study, you can come to a conclusion, because the data says that whether the kit is passing or not. So this is called a statistical quality control. So use a statistical method, statistical data analysis, and you can identify the trends. So before 2 years, the same kit has come. I have done so and so, so and so. At that time, I have got this result. But after 2 years, whenever I am getting the kit, so I am getting so and so results. Like for example, 2 years before, I used to get 500 nanogram per microliter from the same kit. And after 2 years, I'm like, every time whenever the kit comes, I'm doing the statistical studies. So after being 10 lot has been produced, or after 15 lots, after 2 years, the same kit is giving only 300 nanogram per microliter. So by using these assays, you will be easily come to know there is some problem with that particular product, even though the yield is within the range, but the range has been reduced. For example, the range is like from 200 to 600. So earlier I used to get 500. So now I'm getting only 300. But still it is within the range, but it is getting reduced. So this statistical value will tell you there is some compromise which has been happened within the raw material, or somewhere, or within the production, or somewhere, even that might be with the person who is doing the quality control. That has to be analyzed properly. So with this statistical quality control and with this statistical data, one can come to this conclusion, so that sorry, so that in future, if again it is getting reduced, so it will create a major issue. It can be like avoided. So just now, which we talked about, the consistent quality, the quality should be consistent. With statistical quality control, statistics data will provide you that kind of information which will help you to avoid many reworks and many wastages. So features of statistical quality control: it will help you to monitor the process. It will help you to control the process. If you monitor the process, then we are monitoring the process. The process is what? It is quality control. So we are monitoring the quality control. While monitoring, we'll come to know that these are all the defects which can happen in the future. So you can control the process. Next is on-site quality control. On-site quality control is nothing but wherever the production is happening, the manufacturing is happening, at that site itself, the quality control should happen. So that is called as on-site quality control. So which involves conducting inspections, carry out analysis then and there itself, so that if there any defect, it will be it will be monitored, as well as it will be reported very quickly. So basically, on-site quality control ensures the products meet quality standards. Whatever it may be, it is a physical quality control or even the testing. So if it is on-site, it will give immediate results within time. So if any rework or something has to be done, it will be done on time. So this on-site quality control is very much crucial. If we go with any of the certifications like CDSCO and all, so this on-site quality control is very much crucial. They demand a on-site QC team over there. So it is also one of the crucial parameter, on-site quality control. Next is off-site quality control. Off-site quality control is nothing but there is like manufacturing site is at Mumbai and the testing site is at somewhere around Nasik or Nagpur, something like that. So this is called as off-site quality control, or in other terms, it can be like we can give it to third-party validation, third-party testing also. At many places it happens. Manufacturing at one place and quality control at other place. So this is also one of the type of quality control, which is called as off-site quality control. So many of the certifications which requires third-party validations also, because since you are manufacturing a product and you are doing the testing, so how will you validate that whether the QC done by your team, whether it is correct or not, whether it falls within that particular limits or not? It can be done by third-party testing. from a reputed laboratory. So now, till now, what we have seen, like what are the types of quality control, what quality control enhances all these things. Now we will see, and we have seen some real-time examples also, which we used to face during our earlier manufacturing process as well as during our quality control process. Now we'll see what is quality control in manufacturing industry. It is nothing but for a particular product, there are a set of procedures and standards which is already defined, and that product has to meet that specified requirements. If that product won't meet that requirement, then it cannot be passed. And in a manufacturing industry, the QC is the stringent thing. It cannot be biased. It should not be biased. Only the quality should come in mind, and the person or the people who are there in the quality control, they should only rely on the data, not on like, so this has been manufactured so and so, my this person is there in the manufacturing thing production area, he is a skilled person, so he cannot make any mistake or she cannot make any mistake, something like that. So it should not come into any into the mind. So on the quality control person should believe the data. Then it verifies the stages of production from raw materials to finished good. So as already we have discussed some real-time issue regarding some of the reagent. So right from the, like in a manufacturing industry, what happens? First, we define our specification. We give it to our purchase team. Like we need so-and-so product with the specifications. Then the purchase team get a pre-shipment sample for that particular chemical or whatever the raw material may be. They give it to us. So we do the QC for that particular raw material, which has come as a pre-shipment sample against one of the standard material. As I already told you people, like always you have to do a quality control against one standard. So we do that. If it passes, we give green signal. If it doesn't pass, we just reject the lot. If it passes, then they will procure it in bulk. It comes to our plant. Then from the plant, the bulk material, again, it comes to us for testing. Again, we assay it. There are many stories with this, like the pre-shipment sample passes, but the actual lot doesn't pass. So these processes is already been set in our company, which cannot be like avoided, or you cannot bypass these process. So it comes to our team, we do the QC, we again pass the lot, then it goes to from the stores, it goes to the stores, from the stores it goes to the production team, from the in the production team they make that particular reagent or whatever the kits. So again it comes to us for QC. So and this the cycle repeats on. So basically this is the thing in like how a manufacturing industry work. I'm just giving you an example of our industry which I'm talking about. Then what are the basic principles of quality control in a manufacturing industry? So first principle is you have to prevent the defects. First focus always has to be on the raw material, because if the raw material is proper, then the finished product, like you can think, okay, the 50% of the problem can be solved. There are many other steps, like the person who is involved in the production, the person who is involved in the QC and everything, cost, everything matters. The purchase team and the upper management team, everything matters. But preventing defects. So basically the preventive QC comes in place. So basic principle, first thing is preventing defects. Next is consistent product standards. Consistent, as we already discussed, here the statistical quality control comes in place, so that you can see the trend, you can like real-time consistency will also be in place. Next is regular testing. So some products have to be tested in regular intervals. It has to be there. there is a set of procedure to do the regular testing. Then again, inspection against predetermined specifications. The specifications are already there, and that product has to be tested against that predetermined specifications with a proper standard. Then monitor production processes. So here, which we have discussed, the production processes has to be monitored very properly, which we have seen like in that on-site quality control, and as well as during the preventive quality control. So these things comes in place, like the production processes has to be monitored properly, whether it has been cleaned with a proper disinfectant, or the person who is working over there, whether he is maintaining a proper protective like PPE, whether he is wearing a PPE properly. Like, because in production, if something, a very little minute hair particle or some dust particle goes, then everything collapses. Whatever the sterility, everything you do, it is like zero, it will come to zero. So the production process which involves sterility is like very much like crucial, and it is very much important to for the production person to be like trained for all these things. And we have like we always maintain a log for that person, whether that person is having any contagious disease, whether he is sneezing. If a person who is working in a production, if he sneezes, we definitely tell that person to go home and take rest for proper medications and everything, because it cannot be allowed. We cannot allow that person to be over there. It will affect the production processes. So you have, the production processes have to be monitored properly so that you can identify the deviations. So if the deviation is identified, the corrective actions have to be implemented so that we can provide a super quality product to our customers. Next, major elements of QC in manufacturing. There are 6 major elements. First is product inspection and testing. First, you have to inspect the product and test as per the parameters or the specifications, predefined specifications. Next is process monitoring and control. So you have to monitor the process, as well as if you find any defect, then you have to control the process. Third is documentation and reporting. Fourth is corrective action and implementation. Fifth is statistical analysis of quality data. So product inspection and testing. So what can be under the inspection? We can give an example like color, something, whether some particles are there or not. So these are all comes under product inspection. Clarity, whether the reagent is hazy or whether it is clear against our predefined specification. Next, product testing. Here the like as quantitative analysis as well as the functional QC plays a major role to determine the functionality as well as the productivity and efficiency of that particular product. So there are some key differences which can be seen between like what is product inspection and what is product testing. Let's see in another slide. So if you see, we have mentioned the feature is focus. So what can be the focus for product inspection? Appearance. Is there any physical defects or compliance with standards? Something like clarity or something like that. So product testing, as such, you will be assessing the functional parameter of that particular and performance of that particular thing. So there comes performance, functionality, durability, as well as safety, how safe the product is. Then the method. So what are the method which can be employed for this? So visual examination for product inspection, visual examination, or any other predetermined criteria if it is mentioned for that particular product in the specification sheet. So for products as testing, so systemic tests often most of the time we do the testing in the laboratory. Then timing after production or during manufacturing. And here in my product testing, you can see like during development or manufacturing and before release. Then depth. So what is the depth of that product inspection? It is like surface level analysis. It is just a physical inspection. So product testing is like in-depth analysis. Then objective, basically both the objective will be like to meet the standards which is already predefined. So next comes the process monitoring and control, as the, I think, which we have already discussed in detail, but still I will tell you. Sorry. Process monitoring. For example, you can see, like, we will see a very simple example, CCTV camera. So we have a very big room with thousands of CCTV camera and many monitors, and many people are being appointed to monitor that. So that is called as what are they monitoring? What the process is going on. That is what they are monitoring. So this can be an example for a process monitoring. So what are all the things which are required for process monitoring? One is continuous observation. Continuously it should be observed. Then only if any defect is there, if someone is facing any issue, so it can be like monitored. So next is data collection. Data collection is nothing but that in that CCTV camera, whichever is recording, it is getting stored. So next is deviation detection. If there is any deviation, if some camera is not working, so it will be detected if you monitor it completely or continuously. Then alarming and reporting. It is nothing but we have a fire alarm. If there is some fire, it will like alarm. So that can be one of the example. For alarming, I'm just giving an example. Process monitoring, alarming is nothing but if you detect any deviation, that particular person should alarm the person who is doing that process, and it should be immediately reported to the senior or to the upper management, whatever is required as per the standard operating procedure. And then it gives, this process monitoring will give you the real-time information. So it won't, like, the data is there, you are doing the monitoring continuously, so it will give you the real-time data. So the examples of for process monitoring can be monitoring the temperature and pressure of an autoclave while the sterilization process is going on, or while doing the validation of any of the instruments. So that can be considered under process monitoring. Next is process control. Process control is nothing but once you monitor the process, once you find the defects, that defect should be rectified. So these are all the following steps: regulation and adjustment. You have to regulate if some furnace like fermenter is on, so you are getting some X and X efficiency, so you want to improve the efficiency as per the protocol, you have to just change the temperature level or something like that as per the standard parameters. You can change so that the efficiency can be improved. So that is called, you can control the process, like which has happened inside the furnace or whatever the fermenter is. So these are all the things. So examples for this is adjusting the temperature of a furnace, controlling the flow of a chemical reaction, or regulating the speed of a machine. So these are the examples for process control. I hope the process monitoring and control is clear. Next comes documentation. We are doing like 10 experiments every day, like 4 experiments every day. But if we are not documenting what we have done, then everything will go like waste. So proper documentation is very much required for a QC person. Like whatever the data is, whether it is passed or failed, the product is passed or failed, whatever the data is, it should be documented in a very proper way and also in a meticulous way. There are a set of procedures and set of formats we provide for our quality control team. I'm talking about our industry, our company. So there, the process has to be like, they have to enter the data, like they have to enter the results, whatever the results may be, whether it is passing or failing, you have to enter the results and you have to document the raw data we say. And some of the examples are result sheets, log sheets, and we can keep along with the supporting documents can be a raw data. Next is reporting. After documentation, it has to be reported to the immediate senior or to the QC manager, so that it can be decided whether you have to go ahead, like pass the lot or to fail the lot. So reporting will be like the data, whatever, along with the functional data, and it can be like charts or Excel sheet or PowerPoint. So next is corrective action implementation. So what is first? What is corrective action first? So corrective actions is nothing but you have identified some defects. So how to correct it in a systematic way and how to implement it. So on the whole, it can be like mentioned as corrective action implementation. So that you like with this corrective action implementation, these are all the following process which are involved. First is you have to define the problem, then you have to identify the root causes, then you have to develop and implement the corrective actions, then you have to verify the effectiveness. Once the corrective action is done, then the effectiveness is not being measured, then this corrective action is of no use. Again the recurrence will happen. So if you have to check the verify the effectiveness time to time, then documenting the entire process, how this problem has happened, how it has been detected, how it has been corrected, how it can be prevented, how it has to be reported. So there is a like if you have gone through any regulatory certification courses or something like that, there is a procedure called kappa, corrective action and preventive action. It just talk about all these things. It's a very big procedure and altogether it's a very big topic, so we are not going over there. So this is called corrective action implementation. Next is the statistical analysis of quality data. It is nothing but once the data is coming in front of you, how you have to like check what are all the parameters you have to check, and what can be the outcome of that statistical analysis of quality data. So that role has been mentioned. So it improved the accuracy, and it helps to like it will make the data complete. And as I already mentioned, like it will give you the consistent data, which is very much important for a company to what to say, to prove where they are and to know where they are and whether they have to improve or already they have improved. It will like depend upon many parameters. So like whether if it is we are in the improved state, then what the next step will be. So all these things will be taken into consideration if you analyze the statistical data properly. It helps to identify errors, it will rule out your inconsistency, and data driven decision making. So end of the day, as a company like us, so we are a data driven decision making company. We don't rely on any other parameters other than our QC data, so that we can cater our customer in a very proper way. So thank you so much all.